All right, our next speaker is Sath Rao, Director of Digital Solutions for Manufacturing at Hitachi. This is a 15-minute presentation on roadmap to accelerating value from AI for manufacturing. So, welcome. This is the clicker, and there's your countdown clock right there. It counts down.
So I'm not hiding behind the podium, but I think they are live streaming it, so I'll be restricted to a couple of camera angles. So good to meet you guys. Very interesting presentations. As you'll recall, the early part of the morning, with a couple of exceptions, was around buying stuff, right? Selling stuff. But somebody needs to make stuff. And then that's what this segment is about, right? Manufacturing. So it's quite often not a very exciting area, but I hope to change your perceptions by the end of this session today. Hitachi, if you guys are not aware of, is a global diversified major. We make everything from electrical equipment to people mover rail systems, automotive subassembly systems, and Hitachi Vantara is the IT arm which I represent. So we have about 150 years of rich OT experience, operational technology experience, coupled with about 100 years of IT experience in terms of not just data storage, but also looking at platforms, IoT solutions, and analytics. Broadly, we'll try to cover, I have a number of slides, so I'll try to do justice, but still try to get it done all within the time frame. We'll look at industry transformation. Some of you might have heard about Industry 4.0 or Manufacturing 4.0, looking at how that is changing several of our industry verticals. Look at a pathway to digital transformation and invariably how AI can also be leveraged to drive value. We have two use cases. One, Hitachi themselves kind of deploying a solution at one of our automotive manufacturing facilities. And an interesting video of a use case for a client of ours, wherein they're kind of using LiDAR as a sensor, but have looped in AI as well to provide some very interesting insights when it comes to quality of manufactured goods. So for those of you who are not aware of, Industry 4.0 is all about the fourth industrial revolution, as they like to call it, right? It's the convergence of cyber-physical systems, wherein data becomes extremely important. And very interestingly, if you walk into a manufacturing plant, you can walk into maybe a state-of-the-art plant, but a majority of those manufacturing plants are in the early phases of transformation, realizing the importance of data and kind of responding to an industry paradigm shift, almost as if a game has changed. The earlier paradigm was that value was always at the top, strategy needed to be set up at the top, and really the workforce was supposed to implement and produce. But the mega trends of personalization, all the way not just for consumer goods, but even for advanced digital technologies, a gas turbine or aero derivative engine, everywhere, I think the models are changing all the way from product to services and then eventually outcome. And what it means is you're selling power by the hour, you're no longer selling a product. And so the empowerment model has kind of flipped around. It's the worker who actually needs access to data, be it regarding quality, be it around manufacturing, et cetera. So they need to kind of act upon this. And really, they're discovering what is valuable in the manufacturing process. And clearly, the answer is hidden in the data. A very easy framework is looking at problems and solutions, known knowns and unknown unknowns, et cetera. And for each one of these quadrants, right, all the way from best practices to good practices to kind of discovering newer challenges which we might never have even perceived is kind of coming to the forefront and really providing phenomenal opportunities for data scientists to add value. In several studies from Bain and McKinsey, they demonstrate that manufacturing really has perhaps some of the highest ROI, next to B2C segments in terms of how data science can really make an impact. So really, manufacturing is kind of gearing up to understand, look, we need to be agile. And then to be agile, it's all about infrastructure ability, data agility, and business agility. One without the other is nearly impossible. So it's kind of a stairway to value, if you will. But infrastructure ability is essentially how you're storing your data, right? Beyond siloed systems, are they secure? The ability of the IT enterprise to actually respond to business stimulus. Data agility is how an organization is able to harness the data and actually drive useful insights from it. But all that doesn't really get you anywhere until and unless you're able to orchestrate organization change and empower people to kind of drive business agility. So on the manufacturing shop floor, machine data, which is kind of different from machine learning, but the data that is generated from the shop floor is significant, quite often in silos, not connected. So the challenges of kind of training a model become kind of difficult, because really you have to first make sure that you are getting access to that data and then really sorting it out, cleaning it up, and then trying to work with not very tech-savvy members. People have kind of used the wrench or the hammer more frequently than maybe a software keyboard. And then so basically, what you've seen is that some of these technologies, like the edge or cloud computing and Internet of Things, are actually accelerating a value inversion and perhaps even an architectural disruption. Those of you who are aware of manufacturing, traditionally you had the Purdue automation layers, you had level 0, which was kind of sensors, level 4, which was the ERP and supply chain systems, et cetera, and everything in between, including manufacturing execution systems. Suddenly that's getting mashed up. And really some of these megatrends that you see, which is around customization, n equal to 1, right? You're mass customizing products based on unique specifications that have to be delivered on site. And then n equal to 0, which is near zero quality defects, not just when they are manufactured, but when they are delivered and are providing an outcome. So the rate of need for insights is unprecedented. So basically, when you try to kind of figure out how do you get customers across this journey, because not everyone is kind of mature, the first 3 levels is just kind of trying to get them to collect data, visualize, integrate, and run some basic analysis. And I think that's the operational part of it. But then the next 3 levels are about how is business and manufacturing actually transforming. And I think AI plays a phenomenal role, and I'll give you a couple of examples. But really, if you look at level 1, visualization and integration, if you walk to a plant floor, they are actually running end-of-day manufacturing metrics. The famed Toyota production system, all engineered through Japanese ingenuity, was all about looking at data to drive decisions. But this was always done at the end of a production cycle. And I think the big transformation here, now with AI, is kind of doing it online with the ability to kind of draw predictive and prescriptive insights. And then eventually the symbiotic insight is about digital twin. For those of you who are not aware, I'll give you a very quick example. At the Fukushima nuclear reactor, after the meltdown, there was need to kind of figure out if things were still contaminated or actually going downhill. So Hitachi was involved in actually training a robot to actually learn and navigate the internals of a nuclear plant, build the model as it went through, and then lo and behold, one of the soft meltdowns actually led one of the steel bars to actually prevent the robot from actually moving. And so basically we had to send in a second robot to kind of go learn from the first one, develop insights, and actually send back critical information in terms of how contamination was still contained and so on. So that's the digital twin or the symbiotic aspect, which can be used not just in the 3D environments, which is essentially dull, dangerous, and dirty, but also in very exciting environments like developing next generation product life cycles for turbines and so on. So very quickly, I think from a manufacturing transformation perspective, based on where you are in the journey, you can use the right subset of tools, and all the way to supply chain and end-to-end solutions, all the way from overall equipment effectiveness to kind of providing the production insights to managers. The first use case that I'll cover very quickly in the interest of time is the example of the solution that we implemented in the automotive subassembly plant. The metal cutting that you see there is almost a state of the art, but nonetheless requires information about the cutting tool bit, whether it's actually doing its job well, is the fluid actually cooling properly, and then eventually you need to kind of get this information not just at the end of the production life cycle, but on an ongoing basis. So our attempt was to work with our internal organizations, in this case the automotive division, and kind of develop, figure out how to access the silos of information, figure out what might be the best use case. And if you go back to that roadmap, the first one was saying, okay, how can we get access to the data? How can we then store it in a meaningful fashion? Look at process quality visualization, providing feedback on an ongoing basis by actually tying information on real-time basis. Looking at process anomaly detection, which is basically saying, okay, is the quality go, no go? Not necessarily at the end of the production phase, but on an ongoing phase by kind of looking at measurements, and then perhaps looking at even anomaly detection, which is figuring out, hey, do we even have a problem that is within the knowns, or is there a problem because we just switched our supplier, and some of the equipment that we are seeing now might actually have a material defect. So the ability to use supervised learning and unsupervised learning becomes extremely important in this case. One of the big realizations was that as we were running through some of these solutions, we realized that quite often when you look at automation, it's thinking about, oh, machines can do it better, so let's give control to the machines. But in the production floor, I think a big realization was that you need to keep humans in the loop. And then therefore, what kind of information needs to be made available to who in the value chain so that they can take decisions in real-time basis. So one of the first process anomaly detections was, well, look, there are quality deviations, and in case we have quality deviations, then how can we alert the operator to take preventive or corrective action? This is within his realms of control, and therefore they can actually take some of these decisions. But if some of these decisions are beyond a worker, then can a production engineer come and draw some insight? So the ability to parse information and make it available to the right people in charge was again kind of an important learning, kind of adds to the next story which we are tying together, which is about humans and machines kind of working together. I briefly talked about this example of using LiDAR. Uses a laser. The output strobe is kind of measured. You can look at all three aspects of 3D depth, 2D color-coded information, and even infrared information, and all this can be streamed live. So one example of how we have delivered this solution, not just looking at offering better sensors to measure information, but also overlaying analysis and AI on top of that is covered in one of the videos that we'll share in a couple of seconds. But basically, what it means is that to a trained eye, a factory supervisor, he's very easily able to figure out something's going wrong. Right? How do we build that intuitive ability of providing those insights in a fail-safe fashion, so that you can really impact quality? So hopefully this video will work. And
address these issues by making use of IoT, Hitachi developed an image analysis system that detects signs of facility failures and deviations in frontline worker motions. This system is capable of judging whether work is being carried out correctly by comparing the data from standard motion models with the data of the actual worker motions and machinery. Address these issues by making.
So that was a short video, but basically what you saw was, in this specific case, the customer had actually completely looked at automating without humans at all, and then realized that there were inexplicable challenges in quality, and they needed to kind of combine humans and machine to work together, because in certain situations, machines can just not take over completely. And kind of working together, there was the ability to kind of deliver value in terms of using very specific AI tools. So what are the challenges then in terms of accelerating this digital transformation journey? Clearly, the first level is kind of the hunting for right value. Are you attempting to understand where you want to use the best of AI solutions, but is there value at the end? It's not just good enough to kind of make it look good, but it needs to really overcome one of those challenges that we had identified in those 4 quadrants. And the next then is kind of accelerating into a proof of concept very quickly, but then don't put technology first, put people first, especially when you're looking at manufacturing. That seems to be the secret sauce of getting people, not just from the development side, getting data scientists to actually work and understand with the manufacturing crowd and understanding what's the value, what's a long-term vision towards digital transformation, and then eventually scaling this to proof of business. And as part of that scaling to proof of business, I think it becomes extremely important to understand that small victories need to be communicated up. You need to team up with various silos, but at the same time, also scale up in terms of getting senior champions to kind of explore repeating some of these successes across different manufacturing locations. But then to begin every digital transformation journey, you need a vision. The vision should also be amalgamated with value. And then remember, it's not a destination, it's a journey. And therefore, as part of that journey, getting yourself to constantly change becomes extremely important. Thank you.